have a very quick optimization trick for you if, like me, you're using lots of physics objects in your scenes. So this is my level map for Cabs of Chaos. This is my downtown map. And as you can see, there are a ton of little prop objects that have rigid bodies on them, and the player can potentially drive into them at any point and interact with them. And it's important to me that my game has lots of physics objects for players to smash, dash, and crash through in order to sort of raise the chaotic energy of the game that I'm going for. There's not an insignificant amount of overhead to having this many physics objects. If we take a look at the profiler, you can see here that a good chunk of the performance is the simulation tick from the physics engine. We're taking a good sort of 5 milliseconds in order to do this. And so that's a lot of the frame budget because I'm trying to hit 60 FPS just in general for single player. And this is a 4-player game, so I want to make sure that I'm getting the best performance I can to make the 4-player experience as smooth as possible. And this is quite an important thing for me right now because I'm taking the game on my laptop to a expo here in Vancouver this weekend. And so I need to make sure that it can run above 60 FPS ideally in single player, so that in 4-player it runs at least above 30 frames per second so that it feels smooth and responsive. Now on this machine, which is my desktop machine, it's decent enough that you don't feel this and I'm getting decent frame times, but on my laptop the performance was not great, to say the least. And so if we take a look at our physics profile here, we can see that we have over 1,300 dynamic bodies being swept over at any given point in time. Now this is wholly unnecessary because realistically there's only a certain amount of physics objects around the player at any given time, but it's simulating all of the physics objects in the scene all at once. I've got a little tool here called my Scene Physics Manager where I can just grab all of the physics rigid bodies in my current scene and just have a cached reference to them at any given time. Let's take a look at what happens if I freeze all of the rigid bodies here. So you can see our frame time drops just significant. That is such a significant difference, which means that all we really have to do is make sure that anything outside of the range of our player is ultimately just turned off, so it's not being considered for the physics simulation, and only a small select group of objects are actually being considered at any given time for physics. Because there's no point really simulating anything behind the player, they can't see it, anything outside the other part of the map, they can't see it. For optimization purposes, it doesn't make sense to simulate those things anyway. And while this is multiplayer, it means we'll have to do it for all of our player characters in the game. The actual distance that we need to cover is probably relatively small, that we're going to be bringing that simulation count down from about 1,300 probably to just a couple of hundred at max. This is a very, very simple script. Essentially, we just have a static manager that's going to be in the root of the scene. We have a list of rigid bodies. I will eventually turn this into a hash set at a later date. I'm not really worried about that right now, but for all intents and purposes and for visibility purposes, it's just a list of rigid bodies. And then a max distance. We also then have a hash set of targets that can register themselves upon instantiation. So essentially, because this is a multiplayer game, I want to make sure that the physics work around all of the players in the game. And so I want to be able to make sure that they are considered in this calculation. But for you, if it's just a single player game, you just need one object, which would be the player. But this should work sort of in a scalable fashion if we do it this way. So yeah, we just allow the objects to register themselves. And this is on my vehicle controller. So when my vehicle is spawned in the scene, it just checks if the physics manager exists and registers itself, and then when it's disabled from the scene, it just deregisters itself. So whenever we spawn a playable character, which is our vehicle controller script here, that's all that that's doing. And yeah, it's pretty straightforward. I have a little editor tool button thing that allows me to just do some shortcuts in the editor. So that's where you see those buttons from. That's just this, if you're interested in that. And it just essentially lets me execute methods automatically inside my editor. And so at edit time, I grab all of the scene bodies in the scene that I care about. I care about the ones that aren't already set to kinematic. That means they're then dynamic objects because I have some stuff that's handled separately. And so I just grab all of those and assign them to my scene bodies. And then on fixed update, I just run an eval distance method that essentially we just set the maximum value. We go over all of our player characters and compare our rigid body's distance to them. If it's within that minimum distance that we set, we disable the kinematic state and make sure that we're detecting collisions. And if it isn't, then we just disable our rigid body and stop detecting collisions. And as you can see, we've registered our vehicle into the script. And now the overhead on the physics engine is much lower, as we are really only currently simulating one dynamic body. So it really is that simple. And as you can see, it doesn't stop any of the physics simulations, because as we get close, they get enabled. And really, objects that are not that far away are being disabled. But if we drive close to them, as you can see, it's then turned it back on. So if I reverse here, you should see that that's then toggled that back on. So it's a very simple script that can have a huge optimization overhead for you, especially if physics are some of the things that you're dealing with. And it shouldn't matter what kind of game you're working on, whether it's a small single player game in a small environment or a large scale open world kind of thing. This sort of script is something that you'll definitely want to have running in your game. This script alone took me from the single player mode running at about 40 frames per second in a build to around 80 or 90 on my laptop here, which in turn significantly improves the performance of having multiple cameras rendering the game for split screen. I'm gonna go back to optimizing and seeing if I can squeeze a little bit more headroom out of this for my laptop for the event this weekend. But let me know your thoughts in the comments down below. Have you got any physics optimizations of your own that you'd like to share? I'm super interested, and I'm sure everyone watching would also love to know. And let me know if this video has helped you. If you enjoyed the video, hit the like button. And if you're new to the channel, then do consider subscribing, as you'll be notified when new videos go live. Or if you'd like to see more from me first, then consider checking out one of the videos on screen now. As always, thank you very much for watching, and I will see you again next time.